All right, so let's do that. So I just want to go through the calculation just to illustrate what's going on. Okay, and it's also listed here. Even though the annual interest is 12%, it's going to be compounded monthly. You know, the account, the balance that is, the loan balance, right? That's going to get compounded. But each month, it's going to be 1%, 12% divided by 12. Because this was the annual interest, it's being compounded each month. And again, we're assuming that the compounding and the payments are made at the end of the month. So let's do it. Okay, good. Okay. I was worried there was an extra slide in there that I did not take out, but this is right what I have. So let's say this is initial, right? This is the month 0. And let's say we borrowed again $1,000, okay? $1,000. Did I say how long this is going on for? I did not say how long it's going on for, but that's okay for now. I just want to illustrate what's happening. All right. Okay, so month 0, right? That's the initial time. The balance on the loan is 1,000. Okay. Now, for prior, okay, so this is the balance from the previous month, right? This amount gets compounded, the loan amount does. So I guess what you could do is you could think of the person who lends out the money, they're keeping it in a bank account that's being compounded monthly. And every monthly payment you give, the loaner or the person who lent you the money, excuse me, puts it back in the account. If you want, you can think of it that way. But anyway, this balance gets compounded 1%. So $10 gets added onto the balance. Okay, you know, the interest is how much they're making. You have to pay that off as well. That's how lenders, you know, like banks, for instance, make money. They lend out money and they make a profit off the interest. Okay, you make your monthly payment, the $100, right? So now the balance, though, is $910. So not only did this contribute to lowering the balance, it also pays off the interest. But now the balance is $910. Okay, so that's the balance. The same process happens again, right? This is compounded 1%, which is $9.10. That gets added on. You make another monthly payment of $100. And now the balance is going to drop down to $819.10. Okay. Here, of course, we're assuming that each month we're making the same payment. I mean, normally in real life, that doesn't have to be the case. We could increase our monthly payment and pay off the loan earlier. But for this class, we're not going to do that. Then here's the prior balance, right? Again, it's compounded. 1%. We get $8.19, you know, rounding off, of course. We pay our $100. Balance comes down even further. But again, the interest here gets added on. And we keep on doing this, basically. Okay? And this number should be, I think, less. So, well, but hopefully you still get the idea, though. Okay? I think row 4, this number here is not correct. Okay? Let me just delete that. Let me delete this row. There we go. But hopefully you still get the idea, though. So there was a miscalculation here. My mistake. I'm sorry about that. But hopefully you can get you can see the idea of what's going on, right? You know, basically the interest, right? You know, that comes from compounding the balance. You know, that's how the lenders make money. It's going down each month, which makes sense because the balance is decreasing. But this is really just illustrating the general idea. And it turns out there is a formula for loans, and that's what this is. P0 is the loan balance. Again, this is at the very beginning, okay? I know it's the same formula we just saw, okay? But that's no accident. PMT is the loan payments, you know, monthly payments, annual payments. So in the example we just saw, PMT would have been $100. P0 would have been $1,000 if we did the previous example here. R is the annual percent rate, the interest rate that is in decimal form, annual though. Here we had this 1%, but that wasn't the annual interest. That was the monthly interest. N is how many compounding periods there are in a year. And T is the number of years this is going on. How long we plan to borrow money, or the length of the loan, in other words. Okay? The length of the loan. And just like before, if the compounding frequency is not stated explicitly, it's compounded as often as we make payments. Okay? We did say that already, but I felt better saying it again. Okay? So if we're making monthly payments, it's compounded monthly, as in this example. If we were paying it off yearly, then it would be compounded yearly. Good. Okay. All right. But again, this was just illustrating what was going on. You're not paying off the loan at once. You're making these monthly payments. So this is more realistic when you borrow money, like for school or something, where you make monthly payments. Or like for mortgages, when someone buys a house, this is really what's going on, this kind of calculation. You make monthly payments, the interest gets calculated, and the balance goes down like this. The interest is how the bank makes money. All right. And now when you do the loan formula, here you're doing many payments, okay? Here we're making many payments. Okay, that's what we're doing. We're making many payments here. This is compound interest from chapter 5. That's when there's only one deposit. For savings annuities, or just annuities, in other words, many deposits in the account. For payout annuity, like the retirement account, once you retire, there are many withdrawals being made. And for loans, there are many payments you're making. And again, this is all on a regular schedule. That's what we're assuming. Once a month, once a year, and so on. All right, so let's do an example. Let's suppose you have a mortgage and you take out a $140,000 mortgage, which again is really a home loan. You buy a house, you put money up front, that kind of thing. And then you pay off the mortgage to the bank gradually, like a loan. In fact, it is a loan. Let's say the interest rate on the loan was 6%. And this loan is going on for 30 years. Now, I don't know if that's how mortgages normally are, but let's just assume that's the case. Although I think they go on for like they can go on for like 30 years, I think. The question is, how much are your mortgage payments going to be? How much would you have to pay? How much would your monthly payments, that's what we do here, be? I know it wasn't stated explicitly here. I will state explicitly, like on an exam or whatever, but here, these are monthly payments. Okay, so I'm missing a word here. It should be monthly mortgage payments. Okay, so again, I apologize for not having that word in there. Okay, but we can use the formula here for loans, right? Our P0, that's the loan balance, right? That's the initial balance that we want to pay off. So that's $140,000. We're looking for our monthly payment, so PMT is unknown. The R, right? That's our interest rate written as a decimal. The N, right? That's how often the balance is compounded. Here we're making monthly payments, so N is going to be 12, right? The monthly payments, how often you make payments, the number of payments you make in a year, equals how many times the balance is compounded. And this is going on for 30 years. So we're going to calculate PMT. So this is our formula with all the data put into it, as you can see. We got to solve for this. So I did put in, this data, okay? And I did try to show the calculations here, as you can see. Okay, so here, what I want to do is I want to solve for PMT, right? So what I'm doing first here, as the arrow indicates, I'm going to multiply both sides, okay, by 0.06 over 12, the denominator, right? We want to solve for PMT. And by multiplying both sides, this denominator goes away. Okay, so now what we have is this. And then, I know I kind of skipped this step, but then what I do is I divide both sides by this numerator. That's what I'm trying to show you here. So this divides, because then these cancel, and we're left with PMT equals all this. That's what we're doing. I mean, you could, I guess, calculate what's over here first and then divide by it, but you don't have to do that. So we have this here. I interchange both sides. And again, this kind of thing I would do like in a calculator, of course. I use my Desmos calculator, the app I downloaded, or you can use Microsoft Excel or Google Sheets, a spreadsheet that is. But basically what you get is this. You know, when you do the calculation, and that turns out to be about this amount. I rounded, of course, to 2 decimal places. Okay. But actually, if you were to look, we actually ended up rounding down when you do the calculation. I think it turns out to be 0.37. I don't remember the digit after here, but you end up rounding down to 0.37. But remember, you want to pay off the loan, right? So that's why I wrote down here $839.38. Instead of rounding down, I rounded up here. I know the book does that, and really it's what you should do because you want to pay off the loan. Okay, I think we're out of time actually, so let me stop here. Okay.